Hello and welcome to Math 131. This video is going to be the first half of week one's lesson. So I'm assuming you've already watched the video on how to copy notes and assignments into your own Google Drive account, so I'm not going to go over that. We will go over everything up to data structures in this video, and then we'll make a second video that covers packages, arrays, and data frames. And all of this will be part of week one. Now, you're supposed to go through and follow along with this video and edit this file notes, or at least the copy of week one notes saved to your Google Drive account. You will follow along with the video, creating new cells if necessary, typing in the code that we go through in the video, and entering in any sort of information in that notebook. It could be a text cell that helps you remember things, or maybe a comment, we'll get to that in a minute, that helps you understand what a piece of code does. But anyway, your task for this video is to go along through week one notes and enter in things that you find important from our notes in order to help you complete week one's assignments. Let's get started. So we're just going to add in a quick text cell that reminds us that we're going to start with variables. Sounds good. Here is a variable in Python. It takes a little bit for Google Colab to get started. So you can see there now the Python code has officially been run, and we have a variable named x. And that went a little bit faster than it did to create the variable. This is not Python being this slow. This is Google Colab being slow. There's a lot of things going on in a Colab notebook, and this is just one of the penalties you have to pay for it. It just takes about a second for any code to run, even if it's relatively simple code. So here's a Python variable named x that holds the value 5.5. That's just what the equal sign does. It says put into the variable name on the left the value on the right. And with this, you can do all sorts of things like math. You can now take the value 5.5 and multiply it by 3.23432. Effectively, at this point, Python is just a really big calculator that happens to do exponentiation with star star instead of maybe you've seen something like this. That is not valid Python code. This is how you do exponentiation, and effectively all the math symbols you want to work. So here's another value where Python does the math for us. X minus 45, 5.5 minus 45, and you could even store this into a new variable. Notice now in this one cell, I typed just the value of y below to get it to print out that new value. Up here, we didn't tell Python to print the value stored in the variable x, so all it did was created the variable named x to hold the value 5.5. In this cell, we didn't make any assignments into a variable. All we did was asked for the result of x times 3.23432, and so it printed some value. Google Colab and Python interact in such a way that they will only print values if you explicitly ask them to print values. But if all you're doing is assigning a new variable, it will not automatically print that for you. Great. That was our quick introduction to variables. We will see more about variables in this lesson, but for now, let's just move on. So we'll insert another text cell, and this time we'll say functions. For the most part, this is a short course on Python that's going to get you up and running to do some sort of data analysis. That means for now, we will use functions, but not create our own. So let's go about using a simple function, absolute value, and we'll plug in the number y to that. Because y stores the value negative 39.5, the absolute value of y is 39.5. This is how functions work in Python. There's a name of a function, and it takes arguments to the function within parentheses. So we are passing the variable y into the function abs to calculate the absolute value of y. Now, if that's getting a little confusing for you, there are such things in Python named comments. They are anything you want to type to yourself or the readers of your code following a hashtag. So you might say absolute value of y. And if you run this cell, Python is going to ignore anything following the hashtag, even if what follows the hashtag is not Python code itself. From the hashtag over is a Python comment. Comments are there for humans to read the code. I have more to say about comments in week 1's lesson that you should be reading through before or after this video. Let's continue with functions. There are other functions in Python. There's one named round that will round a number to the nearest integer. So you can see this got rounded to -40. But you can also say something like round n digits equals 2. And in this case, because you're asking to round a decimal number that only has 1 digit to 2 digits, it effectively just gives you the value y back. But what we're really showcasing here is keyword arguments. This is a keyword argument. We're saying to the function round, there's another argument we're going to call out by name, n digits, and it specifies how many digits we want to round the value we pass into the function just before it, how many digits we want to round this number to. So for instance, you can see if we ask for y times some number, such that we know we're going to get more decimal places, we are still constraining the function round to only print out 2 digits. And you could put other values here if you wanted to. So here we have a keyword argument. And this argument that is not specified by name is a positional argument. And this is how you generally use functions in Python. You call out the name of the function you want, and within a set of parentheses, you specify the appropriate positional arguments and or keyword arguments. The thing you really need to be careful with is the keyword arguments must come after all positional arguments. One thing you might see online, or if you go get code from some LLM, is that positional arguments keyword arguments do not necessarily need to be specified by name, but I strongly encourage you to specify keyword arguments by name because they are there to help you and readers of your code better understand what that number 3 is doing inside the function round. Great. Now we know a little bit more about how to call and use functions from the world of Python. Just like we're going to create more variables in this lesson, we will use more functions in this lesson, but that was at least a good first round introduction of variables and functions. Let's move on to a slightly new topic, types. The variables we've created here in Python have all been numbers, but in fact, all variables have types. So the type of x is float. That you can think of as any number with decimal values, but you could also ask for the type of, say, just 3, which is an integer because there's no decimal values on it. Well, there's other variables you can create in Python, like a string. So I'm going to call this variable s to help remind you that s holds a string. That is not a standard technique in naming variables in any programming language, but I think it should help you learn what's going on here. So here we've created a new variable named s. S holds the string Edward It didn't print anything for us because we didn't ask it to. If we want it to print for us, we could just put S in a new cell, or even the cell above as the last statement in a cell, and then run that cell again. So here you can see S holds the string Edward. We could also ask for the type of S, and it'll tell you the type of S is str, to stand for string. Strings can be anything you want inside quotes. You could actually use double or single quotes, but I'll most commonly use double quotes. And so then, if you rerun this cell, you'll see we now have a string that helps you understand you can really put almost anything you want inside quotes, and you get out a string of those things. There's some other types that are going to be important for us. In Python, there is Boolean values, which is why I'm naming this new variable with a B. Boolean values can only have two values, true or false. Those are the only two values a Boolean variable can have. Okay? So there's a bool B with the value true. And let's just be silly for a minute here. Let's create a new variable named C, and we're going to put in to C a string named true. And we're going to ask if C is equal to B. And it's going to say it's not. And that is the correct answer in terms of programming languages. And this is because B holds the value true, which is explicitly not a string. It is a Boolean type. C, on the other hand, is a string that holds the English word, capital T, true. These are different values in the world of computer programs. This one's a Boolean, this one's a string, hence these two things are not equal. These double quotes surrounding the word true are thus important. That's what specifies for us a string in the world of Python. There are some other types that we're going to see in Python, and those types are going to come in the world of data structures. They are variables that hold multiple elements of some type. So let's create a list that we're going to name L. And we can stick some numbers in L. Remember, Y holds a number, S holds a string, B holds a Boolean, and we might also just type out some other numbers here. This thing is called a list. A list is a data structure stored in a single variable named L, such that L holds many different things. You can see that the data structure list can hold floats or ints, even though we don't have any ints in this list. It can hold strings, it can hold booleans, it can hold other floats that you type out by value instead of by variable. Lists are considered a heterogeneous data structure. It is one variable that holds many things. The many things within that list do not all have to be the same. And that's a list. Lists you should think of as an ordered collection of things. Ordered meaning that you can access by number some of the elements within the list. So you'll notice L indexed by the integer 0 gives us what you might call the first element of the list. Python lists start with index 0. That's a feature or bug of Python depending on your personal preferences, but whatever your preferences are, that's how Python works. So we will go on and access the first element of the list, L, which we now see is the string stored in the variable S. Here we are indexing with integers the values stored in the list L. You could also do more exciting things like this. You could ask for a sublist. That is a list of just some of the elements of the list L. So if you type in L indexed at 0:2, you'll see you'll get indices starting from 0 and up to, but not including, whatever you put on the right of a colon. So notice L of 2 is the value true, corresponding to the variable b. But if you index with a slice in a list, you will get indices starting at the left index 0, going up to, but not including, the right index 2. So this slice goes through integers 0 and 1, but excludes 2. If you wanted to include the second one, you'd have to put 0 to 3. This is called indexing a Python list. There is much more advanced indexing you could do with Python lists, but for now, it's noted, we should note, that slices start at index on left of colon and exclude index on right. And you should play around with this until you best understand the slices. So effectively, go create your own list, pause this video, go create your own list, whatever variables you want in it, and then practice indexing them with slices or just integers until you get a better grasp of the data structure list. We're going to move on, though, and create our last data structure for this video. It's a dictionary, and dictionaries are created with curly braces instead of square brackets. So here I'm going to create a dictionary that holds, let's see, key math, value 131, Chico State. Great. Seems fancy. So here is what's called a dictionary. A dictionary is like a list, except instead of indexing the values stored in the list with integers, we index the values stored in a dictionary by key. Seems is the key for the value fancy. Chico State is the key for the value great. Math is the key for the value 131. So dictionaries are effectively key value pairs. The benefit of having values accessed by keys is that you can index a dictionary, you can index a dictionary D by the key and get out the value 131. You can index a dictionary by any of the keys stored in it and get out the value associated with that key. So here are two data structures in the world of Python. Lists have indices that are integers, so it's almost like you should be thinking of the elements in a list as in the order specified by the integer indices. However, dictionaries don't have any obvious order because math and Chico State and seems as the keys are not necessarily in any obvious order, but we can still access the value associated with these keys. That does seem fancy. One other thing you can do with dictionaries is you can assign into, let's say, number equals y. You can assign with an equals into a key that doesn't previously exist some value and thus edit the dictionary in place. So now we have an additional key value pair where the key is number and the value is the variable y that we created above. Throughout Math 131 and basically anytime you use Python, you are going to be creating variables to be used with functions, and often you'll want to store the variables or the outputs of the functions in some sort of data structure. The two most common data structures in Python are lists and dictionaries, though there do exist other data structures that we won't be touching on right now. I'm going to call it there for the first half of week 1's lesson. And in a new video, we will move on to the second half of week 1's lesson.